Hey and welcome back to our channel. Before we jump into today's tutorial, we have some big announcement. Once a year, How to Rhino organizes a free workshop for everyone interested in learning Rhino and Grasshopper. This year it will take place from May 27th to June 6th, and we're going to host in-depth training session for Rhino, Grasshopper and Rhino inside Revit. So in total we'll have 4 pre-recorded materials and 4 live events. I can promise you there will be something for both total beginners but also for advanced Rhino users. And here is the fun part. The workshop will be held on our new How to Rhino community platform. At the time of this recording, 4.8 thousand people already join us. And this is the place where we want to bring together all our YouTube subscribers, Instagram and TikTok followers and our course members. So here you'll be able to interact, post questions, share your work, help each other and attend our live events. And if you're watching this video from the far future, unfortunately you won't be able to participate at our free workshop, but the good thing is that the join link will still be working and you will be able to join us and be part of the How to Rhino community. And here are the benefits of being a member. The whole community is gamified, which means you can earn points by posting valuable info and helping other people. By earning points, your account will level up, and at a certain level, you will be able to unlock different perks, such as attend our group live meetings, recordings, access to our extended video tutorials, and even get a discount code for any course you'd like. So simply by being active and helpful, you're making the whole community more valuable. So if you want to join us and attend our free workshop, click right now in this link or in the first link in the description. Now let's dive right into this tutorial. Alright, so this tutorial is divided in 4 parts. In the first part, we are going to create 3D walls from the list of lines. So imagine you want to sketch some simple floor plan from the lines, and we can easily convert this into 3D walls. So you can see it here. And for example, if I want to move this wall somewhere here, it will be automatically updated. Alright, and for that I will use flexibility plugin. I highly recommend you to install it because it contains super cool components. I will show you later on some other. Alright, in the second part we are going to create a floor plan from these walls, and also I will show you how we can create the hatches. So hatch component is the new one, and it comes with the Rhino 8. So I will show you how we can create hatches, how we can customize them, and so all the features I will explain later. Third part of the tutorial will cover line types. Line type is also a new component, and I will show you how we can create customized line types in Grasshopper. And the fourth part of the tutorial will cover annotations in Grasshopper. So with these tools that comes with Rhino 8, we'll be able to annotate our drawings in Grasshopper, and you will see if I turn this on how they're displayed. And for example, if I want to take this line and I move it somewhere here, you can see how the floor plan, the hatches and also annotations are updated. So like all the features I will explain later how we can set our own styles. So for instance, if I take these walls, I delete them, you can see how everything is synchronized and how hatch is modified and also annotation. If I undo, it will get back to the previous stage. Alright, so first I'm going to use curve container and I will reference all the lines. Okay, now I will open the flexibility plugin, and here you will find curve region component. Connect the curves with the curve region and we'll get 5 different polylines. If I turn off the curves and if I turn off the layer, Okay, you can see that we managed to create regions from the list of lines, and we can use boundary surface to generate the surfaces. But if I bake this one, you will notice that one surface is flipped. So if we want to unify the orientation of all the curves, we can use another component from the flexibility plugin, and the component is called curve orientation. So I can connect output with the curve input, and here we get two different outputs. In the curve orientation, we get the result if it is a counterclockwise or the clockwise orientation. We can see that only one polyline is it has clockwise orientation, which means we need to reverse. I mean, we need to flip it. In order to flip, we get also the output value 1 and -1. 1 is for the counterclockwise, -1 is for the clockwise. So we can use component equality to create two different lists based on the orientation. And I mean, value should be connected with equals, and in the B I will set 1. Okay. And based on the pattern that we get, we can create two different lists. So I will use dispatch pattern from here, and I will connect a list with the curves, with the regions. I will turn this off, and I will delete the surfaces. So here we get the curves with the counterclockwise, and the B we get with the clockwise, and this one we can flip. So I'll use flip curve, and now I'm going to merge these two lists. And now if I use a boundary surface to create the surfaces, bake, there is no flipped surfaces anymore. So this is a great way to unify the orientation of the closed curves. And in the next step, I'm going to join these surfaces with the brep join. Let me turn off all of this, and I will delete the curves that I baked. All right, so using this brep, we can separate the inner edges from the outer edges. Why I want to separate them? Because I want to set different thickness of the walls. So I will use brep edges, this one, and in the EN, or the naked edge curves, we get only the outline, and for the edge interior we get the edges inside. Maybe we can use draw full names. It will be easier for us later on when we have plenty of inputs and outputs. Okay, now I will take these guys, and I will show you one other component from the flexibility. So I will type offset curve. I think it's with a plus. Yeah, this one, offset curve. So here I will place the curves. Here we should get in the distance, we should define the thickness of the wall. So I will set 0.075. Okay, but I want to have offset in both directions. So we need to set true for both sides. So I will use toggle, and I will place true. Also, one step I forgot, I want to join all these guys. So I'm going to join them first, and then I will place in the offset curve from the flexibility plugin. It is placed here. It's not visible because of this window. All right. Okay, I will place this back. So we managed to create a single region. So if I use boundary surface. We'll get a single region for the walls, for the exterior wall. Maybe interior walls can be 0.15 because this number is doubled. But the exterior wall can be 0.3. So now I will simply copy all of this, connect with here, but I will place here 0.075. So you can see how we can easily create the walls from the lines. But there are more steps. First, I want to create a single surface from these interior lines. So first I will flatten this one, and we get 3 different surfaces. And if I use a union region, maybe first we should use union region, and now we can create a single surface. Okay, let's create the walls. So I will extrude these surfaces, and I will extrude along Z direction, and I will use same value, let's say 2.8 for example. In order to create a single close B-wrap, we can simply use these 2 B-wraps or close extrusions and use a Boolean union to join them. But I don't want this connection. I don't like this connection here. So I'm going to first split Boolean, so to remove this small part. And once we remove it, I'm going to join them. So one more component from the flexibility plugin, and you can find it, I think, somewhere here. Yeah, in the surface Boolean split. Keep in mind that you need to have the latest version of the Boolean split. All right, so now I will take this guy and I will split with this geometry. I will split this one because I want to remove the small part. So I will place in the B-wrap. Cutters will be this B-wrap. Okay, tolerance I will keep by default. And in the output we get 7 closed B-wraps. Why we get 7? Because here we get one more B-wrap, here as well, here, and here. And here we have 2. So I'm going to calculate the volume, and I will sort them by the volume. And by default it is ascending order. But if you want to have descending order, we can simply reverse the list. And I will only take the one with the largest volume. Okay, I will turn all of this. And now we can simply use Boolean union to join these 2 geometries. So union, solid union. First, maybe we can place in the same list these 2, and I will connect with the solid union. You can see this dashed line represent we have data tree inside. So if we want to flatten and to place these 2 in the same branch, I will flatten, and now we can create a single closed B-wrap. One more thing that we can do is to merge these planar faces. So I will use merge all coplanar or merge faces, this one. Turn this off. And if I use this geometry from the B-wrap output, we get the geometry that we need. All right, now let's create the walls and doors. I already prepared the geometry and we have it here. Doors are placed in the layer doors, windows are placed in the layer windows, and I'm going to reference them. So once I reference them, I will create the holes on this B-wrap. To reference these 2 layers, I'm going to use pipeline components. So I will type pipeline, geometry pipeline, And here I will type windows. Okay, and I will create another one, double click, and I will type here doors. Okay, so what I want to reference from these layers, I want to reference brep and brep also here. So here we get windows and here we get doors. I'm going to merge these two guys and I'm going to use solid difference. Okay, brep A is this one, brep 2. Okay, I will turn this off. I will turn off these two layers. And we managed to create some simple 3D walls with the openings for the doors and windows. Okay, so now I want to show you how we can create the hatches or how we can create a floor plan from this geometry. I will use first brep plane. So I want to split brep, this one, with the plane. So I will use XY plane, connect with the plane input, and the origin point we're going to construct here. It is only important the Z coordinate. So the Z coordinate I will place at height 1.2, for example. Okay, and you can see that we get the section with the brep and the horizontal plane. Okay, now this one or this plane I want to position next to this geometry. So I will use like this point, set one point, I will place it here, and I will use this as a target point to orient the whole geometry. Actually, to orient only the section. So I will use orient. So this is the geometry that we want to orient. Target point, or target plane will have origin here. We just need to define source or initial plane. Initial plane can be defined if I define the bounding box, right click and choose union box. Okay, and I will take only like the surface from this box because the box is flat, and I will simply find the center of the surface, and this surface will be the origin of XY plane. Okay, so if I take this point and I move it, the floor plan will be moved as well. Now I will show you how we can hatch this floor plan. So I will go into Rhino tab, and here you will find component model hatch. Okay, so there are plenty of inputs. I'm going to use first this geometry, the output from the orient, and we should place it in the boundary. By default it is set to solid pattern, but I will show you how we can get different patterns, different hatches. So I will search for component query model hatch, so this one, and with this component we can add default patterns or we can import some patterns. So I will use add default patterns, and by default it is already activated synchronize. I will keep it like this, and I will add default patterns. So if I use the panel and connect with output, we managed to import 9 different default patterns, and we can simply use with the list item which one of these we want to choose from 0 to 8. So for instance, I want to use hatch grid 60. Okay, and hatch pattern I will connect with the hatch pattern input. So now we can rotate the hatch, let's say from 0 to 180, but this number we need to convert into radians. Okay, degrees to radians, place it here, to rotation. Okay, and we can also scale. So we can scale the pattern, and then we can either use to display the boundary. So with the true and false, by default it's set to false, but if we want to show the boundary, you can set to true. Then you can choose the background color. So let's choose some color. Okay, so if I want to define base point, and I will say, okay, base point for the hatch should be here. So first I need to orient this point from this geometry to here. So what we can do, we can find the larger line from these two. This is smaller with the index index 0, but if I use index 1, we get the larger polyline, and this polyline I'm going to orient the same way that we orient the whole section. So I will copy this one here, and I will this geometry or this polyline, and the source plane only will be different. The target plane is the same, but I will use the same logic. Find the bounding box, extract the surface, find the center, and this center will be origin of XY plane. Okay, so we managed to take the outline and position it where the floor plan is, and now we can use this continuity and find the corner that we want to use as a base plane of the hatch. Okay, oh sorry, not level, but I need to use list item. Let me find, so this is index 0, 1, 2. We need index 2. Okay, this point should be base point of the hatch. And if I zoom in here, and if I rotate, you will see that the hatch is rotating from this point. Okay, I will turn this off. Maybe we can change the display to black. Okay, now I will show you how we can create the custom pattern or custom hatch. So there is component here, model hatch pattern. So I can take this hatch, place in the hatch pattern, and let's say I want to use hatch 1, let's see what we have here. Okay, hatch 1, and hatch 1 contains only one line type, but we can modify this line type. So I will take hatch lines. You can see that here we have only one hatch line, and go to drafting, and you will find the component hatch line. So hatch line, I will connect with hatch line, and now we can customize this hatch line. Okay, so here we can define the shift, the offset, the segments. This segments is really cool because here we can define the gaps if we want to create dashed line. You can see here a list of segment lengths. Positive values are interpreted as a line, negative values are interpreted as a gap. So now we can create two different values. Let's say 0.05, and maybe we can simply create the negative value of 0.05. I will place in the segments. Okay. After that, I will use once again model hatch pattern, copy. So this hatch line will be placed here. This is the hatch pattern, but it is really important to give a different name here. So let's say my hatch pattern. Connect with the name, and this hatch pattern will be used. Okay, so here you can find how we managed to create different hatch pattern, and you know, here we can modify it if you want, and even we can place two different values if you want to have like smaller gaps and larger line. Also, we can define the offset here. So these are the offset between the lines. Also, we can define the shift. Shift means, let me go in the top view. If we want to shift these lines, so right now they're not shifted, but if we, you know, change the slider, you will see that, I mean, how they're shifted. So now you learn how you can create custom hatch pattern. I want to add one more thing here. So you can see here that we have horizontal lines in the hatch, but if I zoom in here, we get vertical lines. Why? Because the orientation of these curves are different. So now we can go here, the curves, and we can use the same logic as we did here. So we can use this logic, or another way is to take these guys, or take actually these ones, and you can use component flip curve, connect geometry or the curves with a curve input, and the guide can be a circle. And if I flip these curves based on the simple circle that will have origin at 0, 0, 0. Let me check, did we manage to unify the orientation? All right, so now you can see that all the lines from the hatch are horizontal. In the next part of the tutorial, I will show you how we can use line type component. This is also a feature that comes with the Rhino 8. And go in the drafting tab, and you will find here model line type. Okay. And also I will use query model line type. So I want to find all the line type that we have. So once again, the same logic that we have for the hatches, right click and click add default line types. And here you will find different line types. Okay. And once again, I will use list item to extract one of these. So from 0 to 5. Okay. And let's use center, index 3. And this line type I will place in the model line type. So in the output, we get the name, segments, the same logic. Positive number represent the line, negative represent the gap. So here we have cap style from 0 to 2, round is 0, 1 is flat, 2 is square. Then we have join type, width, and width units. By default is set to pixels, but you can change this, right click in the width units, and you can I will use document units, this one. Now I want to create dashed or maybe the center lines only where the windows are positioned. So only here, 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 and here. So how we can do? First, I will take only windows, so only this one, and I will find the intersection between windows and walls. So I will use solid intersection. Okay, I know why we have empty, because we need to graft the input brep B, and in the result we get 4 closed breps, right? So I will flatten this one, and maybe we can move it somewhere here, and also these line types. Okay, now I'm going to use the same logic. I will use brep plane. I will use the same plane, and I'm going to intersect with these 4 breps, and we'll get 4 closed polylines. Now I want to extract only, first I will extract all the segments, but I want to keep only 2 larger segments, yeah. So first I will explode polylines, and I will calculate the length of the segments, and I will sort segments based on the length, and I will reverse the list, because as I said, by default is set to ascending order. But if we reverse, it will set to descending, and we can extract only items with 0 and 1. These two are 2 largest segments. Don't forget to right click and uncheck multi-line date. Okay, now we have 2 segments, and these 2 segments I want to orient here. So same logic, I will use the same target and same source plate, only the geometry will be different, and I will flatten this one. Okay, so once we get these lines, I want to change their line type. To visualize the lines, you can go to display, preview, and you will find here custom curve preview. Okay, so here we have curve, and here we can choose the color and the line type. Let's use red color, and here we can use the line type. Okay, we get this result because the width is too big, but if I choose some really small value, we'll get, you know, different the different result, but we still have the continuous line because the segments are too big. So 2.5 and minus 0.5 is too big, so that's why we need to change the segment. So I mean, we're able to modify it. So let's use merge, and before that I want to check first so how many values here. So we have 4 different values, so we have 4 inputs, and okay, 0 and 2 are positive values. So let's say 0.2, and this will be 0.05. This will be negative. Okay, 2 and 4, this will be in the 1, and let's say this can be 0.1. Okay, let's see what we managed to create in the segments. All right, let's go in top view. So here you can, you know, modify the gaps, the length of the lines, and in general you can, you know, define the line type that you need. Let's see what will happen if we change the cap style from 0 to 2. By default set to 0, but this is 1 and this is 2. Let's set to 1 and join style. Okay, here we cannot see join style because all there is no angle. All right, and if you don't want to use any predefined line type, we can simply, you know, disable this one, but we need to assign the name. So I will assign my line type, place in the name. Okay, and for example, we don't want to have 4 different segments. We can have only, let's say, 2. So I will delete this one. I will unplug this one. And here we get simple dash line. In the last part of the tutorial, I will show you how we can create dimensions for the floor plan. So go to Annotations tab and you will find Align Dimension. So first I will explain you how this works. Imagine we have a line and we need to take first segment or first end. So this is A and this is B. So A should be placed in the point A, B should be placed in the point B input. Once we have these two ends, we can define the dimension, and here in the offset we just need to define the distance between the dimension and the original line. So this size plane is the plane where the dimension will be located, and here we can place if you already have aligned dimension style. Okay, but what if we have a rectangle, for example? What is A, what is B? So if we have a rectangle, I'm going to extract contour points. So these 4 points, and this point will be A1, A2, A3 and A4, and all these points will be placed in the point A. I will take this list of points and I will shift by 1. If we shift by 1, let's use another color. This point here will be B1. This point here will be B2. This is B3 and this is B4. If we take this shifted list of points and place in the point B, we'll calculate the distance between A1 and B1 and we'll get first dimension. Then we'll calculate the distance between A2 and B2 and we get second dimension. And the same logic for all segments. Okay, so first I will go to model hatch and I will extract hatch boundary. Okay, so if we take hatch boundary, I'm going to flatten this list and I will use this continuity to get all contour points, but I need only contour points that are placed on the outline. So what we can do, I will use component point in curve, this one. The curve or the boundary region can be curve that we already orient before once we extract the point used for the base point of the hatch, this one. So I will use this curve and I will place in the curve input of the point in curve. Okay, here we get the relationship. 2 means that the point is inside, 0 means the point is outside, and 1 means the point is placed on the curve. Let's have a look. I will use equality and I want to find the points that are placed on the polyline. So I will use then number 1 and let's use cal pattern. Okay, now here we should get only points that are placed on the polyline. Okay, once we get these points, I will flatten the list and now I want to sort these points. they need to be sorted in order to have like proper dimensions. Sort along curve. So these points I want to sort along this one. Okay. And let's visualize point a list. I want to visualize if we have a proper distribution of these points. So 0, 1, 2, 3. Okay, this is correct. Now we can, shift the list and create point A and point B. Okay, let's use this one. So first one will be in the point B. Shift a list. We can either use -1 or 1, it doesn't matter. It is really important to keep here by default true value, because we want to have the same number of points in the point B. Okay, and we managed to place the dimensions, but dimensions are oversized and we need to adjust it. So if we right click here, you will find the option show all parameters. All right, and here we can define the offset. The offset won't be visible because the numbers are too big. I will get back to offset later on. But we have text settings, dimension settings, arrow settings, units, and tolerance settings. Okay, so first let's start with the text settings. Once again, go to Rhino tab, annotations, and find text settings. Annotation, text settings, this one. Okay, once again, a lot of inputs and outputs. And text settings, I will connect with the text settings outputs, and here we can define the text height, gap, mask, so many features. Let's start, font I will keep by default. So first I will define text height. So let's say 0.1. This will be the text height. Okay. Text gap. This is the gap between the line and the text. 0.1 is okay for now. And then we have mask frame. So we can either choose not to have any frame, then we can use rectangular or capsule. So 0, 1, and 2. If we set to, let's say, capsule number 2, we can define the color and margin. Then we have text oriented. I will keep this by default. Horizontal. Okay, all of this I will keep by default. And we can define here how the text will be displayed. So 0 is auto. Then we have text inside, text on the right, on the left. Let's see. So from 0 to 5 is auto. Okay, I will keep this by default. I will get back later. And this is how we can, adjust the text. But what I really want to change right now is the arrow settings. So I will modify the arrow settings. I will get back to dimension settings. So once again, go to annotations and find the arrow, this one, annotation arrow settings. Okay, place it here, and here we can right click and we can choose the type of the arrow. I will choose tick, and I will, for the arrow 2, I will choose tick as well. And now let's define the arrow size. Okay, now it's much more cleaner. Let's say 0.1. Okay. Fit arrow from 0 to 2. Let's see what we have here. This is 0, this is 1, this is 2. I don't see any difference right now. Probably I will see the difference if we change other settings. Now I will go back here to offset. So you can see that all the dimensions are placed inside of our floor plan. And we can see here that offset is set to 1. But if I use negative value for the offset, and here let's say I will set to 1. Okay, now it is placed on the outside. Okay. Let's say 0.5. And now we need to modify dimension settings. So go to annotations and find annotation dimension settings. Okay, dimension settings will be placed here. So if you want to have some, predefined dimension settings, arrow settings, text settings, you can go here to annotation style. Okay. And we can also query annotation style. In my case, once I add this guy on the canvas, I get single output, which is meters architectural style. And we can connect with the annotation style. And I can give name my annotation style. And these text settings I can place here. Then we can dimension settings and arrow settings. So you will apply this method if you want to use some predefined annotation styles. In my case, it doesn't change anything. And now let's get back to annotation dimension settings. So first we can define if the dimensions will be oriented to our view. So if I set to true and I go in the perspective mode, you can see how the numbers are oriented to the view. But if I set to false, they will be placed on the XY plane. Then we have text location. Let's see, from 0 to 2. And we can define whether will be above, on the line, and below. I noticed that this below doesn't work. So I will keep to 0, above the line. Then we have option for the text rotation. Text is horizontal. Text is aligned with the last letter direction, and text is rotating using explicit angle. In our case, I will use text is aligned with last letter direction or dimension line. So this is option 1. Radial option I will skip. Then we have dimension line extension. Okay. So let's see what it will change. So you can see that we can define for how much dimension line will be extended. And I will set to 0.1. All right, to understand better extension line extension, first we need to define extension line offset. So this is the offset. Let me show you the offset from control point. So if we set to 0, the dimension will be intersected with the control point. But here we can offset, let's say 0.2. And if we go back to the extension line extension, we can define what will be the length of this line from the arrow. So this is the starting point. I will set also this to 0.1. Okay, let me show you if we use a fixed extension. Right now it's set to false, but if I set to true, we can set the fixed extension, and this can be set here. So to understand what fixed length extension, basically it creates this line from this point here. So if this line is 0.1, this one here, we can set that this line here can be also 0.1. Let me show you. Okay, so this is if you want to use fixed line extension. If you don't want, you can set to false. Alright, and now I will show you how we can modify the units. So the unit settings should be placed here, and we can find the annotation unit settings component. Okay, so the output I will directly place here. Alright, so I will start with linear resolution. Basically it means how many decimal numbers we're going to have if we use decimal numbers. So I will set from 0 to, let's say, 6, and if it is set to 0, I will not have any decimal numbers. But if I set to, let's say, 3, we'll have 3 decimal numbers. Okay, now let's go to length units format. We have 10 different options here. Okay, let's check all of them. If we set to 0, it will be decimal model units. Then we have let me check fractional inches, feet and inches. And then we have millimeters, centimeters, meters, kilometers, and so on. So you can define here the units. I will set to 0, so it is decimal model units. Now we have the length factor. In 99% of cases it should be set to 1, but if you want to modify 1 means that it will display the true value of the length. But if we set to 0.1, it will display 10 times smaller value than it is in the model. Okay, I will set to 1. Linear resolution we already defined, and now we have round off. Round off means what the last digit will be, or what the last digit will be rounded. So we can, if we have 3 decimals, I will simply explain here. If we have 3 decimals, then we can round to 0.005. So either the number will be 0, third decimal, or 5. And I will place here. So you can see here that the third decimal is either 0 or 5. Alright, then we have prefix, suffix. Let's say suffix can be a space and meter if you need. Alright, I don't want suffix. Then we have fractional format. We don't use fractions, so that's why I will skip. After suffix, there is also one important feature for the 0. So 0 suppression, which means how the 0 will be displayed. So no 0 suppression, suppress leading zeros. Maybe I can show you here simply 0 to 12. So right now we don't have any suppression. So if we set to 1, there is no leading 0. But if we set to 2, there is no trailing 0. So if we have, let's say here 0, there is no 0 in the end. If we set to 3, it will combine first 2. So it will remove 0 at the end, and it will remove the 0 as a first digit. Then we have what is 4. 4 and 8 and 12 are related with the feet and inches, which I will skip for now. So you can see how we managed to create dimension style. And now let's take this Windows and ball, and I'm going to move it. And you can see how dimension is modified. Let's see if I delete this one. So let's focus here. I deleted the window and dimension is modified, and also the hatch is modified because there is no window anymore. Also, if I take, let's say, this wall, I copy and place it here. I don't have the result because we need to recompute as I use pipeline. So I will press F5, I will recompute everything, and now we get one more door here. And we get one additional dimension. Okay, now I will show you how we can create dimension lines inside. So let's say I want to have dimension line somewhere here, 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 and let's say here. Okay, so first I will create this one. And this one is placed, we need to find the plane where this one is placed. It is placed in this plane here. This plane is XZ plane. So first we need to find the origin of this plane. And the origin we can get if we take, let me find this outline. So this curve, and I will extract the surface. I will create a surface, and I will evaluate this surface in order to find the point. So don't forget to reparameterize surface, and in the point input I will place MD slider. Okay, and let's define the position. So this point will be origin of XZ plane, and this plane will be used to cut this geometry in order to find the intersection. So we use brep plane, similar to what we did once we created the floor plan. So this is the plane, and brep I will simply connect with this one. I will turn this off, and I will use hidden wire. Okay, here we have 3 polylines. I will extract its corner points. These corner points I will project. So I will project is on the plane, and the plane is XY plane. I will keep this by default. And all these points, so you can see here that we have, we should have 6 points. We see 6 points, but actually we have 12 points. Why we have 12 points? Because here 4, 4, and 4, and all these points we projected on the XY plane. Now I want to flatten them, and I want to remove duplicated point. I will use leave 1. And now these points I want to sort. So maybe we can turn off this for now. And I want to sort these points based on their coordinate on the plane that we use to cut. So to find the coordinates on the plane, there is component closest point, plane closest point, this one. So these are the points, and this is the plane, and we get UV points. And based on, here we get the X value. Now we're going to sort these points based on their X value. So we'll deconstruct the points and sort the points based on their X value. And once we sort the points, we need to orient them where our floor plan is. So to orient, to position the right place, I will use orient. This is the geometry that we want to orient, and we need to have source and target plane. So target plane will be the same target plane that we use all the time. And the source plane will be similar to this one, but without Z coordinate. So we'll take this point. And this point I'm going to simply just deconstruct and construct the same point without Z coordinate. Okay, construct point. And XY plane, origin of XY plane. And placing the target, on the source. Correct. Once we have the points, we can simply use the same logic. Shift by 1. This is the list. -1 to 1. So we're going to shift by 1. And now it is really important to set false, because previously we have the closed point line, but now we have this line is not closed. Okay, and I will copy this one. Just the A and B will be different. This is A, this is B. Okay, and the offset, we don't need the offset. Offset will be 0. All right, and if I change this position of this line, we can get, different. We can get different dimensions. And if you want to create, let's say, dimension here, here, and here, I will take all of this, copy. But the only difference is the cutting plane, which in this case will be YZ plane. This is the only difference. And now we can, find the, let's say, this dimension here. And I will copy and move this point, find dimension here. Once again, copy, paste, and find dimension here. Alright guys, I hope you enjoyed this one. And if you want to know more cool Grasshopper features that comes with the Rhino 8, feel free to watch this video, and see you in the next one. Bye!